A very good morning all. In this video, in this lecture series, I will talk about signal and system and its physical significance with the example. In the today lecture, I will talk about introduction of signals and its classifications. So, what is signal? We will talk about what is signals. Signal is a mathematical function which convey the information. The signal is the function which convey the information, and mathematically we can represent a signal in terms of s of t, where t is your independent variable. So this is a one dimensional signal, and there is a multi-dimensional signal also which we can going to represent s of t1, t2 up to t of n. This is single variable signal. This is multi variable signal. So here we can classify a signal into two categories. One is called as a continuous time signal, CTS, and another is the discrete time signal. So we can categorize a signal into two categories. One, we can say a continuous time signal, and another is called as a discrete time signal. What is continuous time signal and what is discrete time signal, that we will talk about here. A continuous time signal, a signal which is defined in all value of time. A signal which defined in all value of time. Defined all values of time. That is s of t, and where t is defined in all the values of time, and graphically, like this is the time axis, this is the amplitude axis. So this is my signal. This is called as a, this is the example of continuous time signal, and another is discrete time signal. A discrete time signal, a signal which is defined a discrete value of time, and mathematically we can represent a discrete time signal in the form of S of n, defined specific discrete value of discrete values of time, and mathematically we can represent a discrete time signal in S of n, where n is the integers 0, plus minus 1, plus minus 2, and so on. And graphically we can represent a signal, the representation of discrete time signal. So the y-axis is S of n, s-axis is n. So here this is the point 0, 1, 2, 3. So suppose this is my values, discrete time signal. At the point of 0, at the point of 1, so here we can see a discrete time signal is defined at the point of 0, plus 1, plus 2, plus 3, plus 4, minus 1, minus 2. The other way of representation of discrete time signal is this. That is 1, 0. We can here represent all the amplitudes. 1, 0, at the point of 0, 1, at the point of 1, 0, at the point of 2, we have a 1 magnitude, at the point of 3, we have a 2 magnitude, at the point of 4, we have a 0 magnitude. One of the very important point that we have to highlight here, in this representation, we are not able to identify where is our origin point. So to mark the origin point at the point of 0, we have a 1 magnitude. So this is my origin. So from the right hand side, from this arrow, it shows the positive side of your axis, and left hand side of the arrow, it shows the negative side of your arrow. So this is the representation of signal. So we have basically two kinds of signals. One is called as a continuous time signal, another is the discrete time signal. A continuous time signal, a signal which is defined in every value of time. So you can see at every value in between these two intervals, there is an infinite values, and all these values the signal has defined. So this is called as a continuous time signal, and mathematically we can represent our continuous time signal S of t, where t is your independent variable. Here we are considering a one-dimensional signal. In the same manner, for the discrete time signal is defined the specific values, or we can say a discrete values of the signal. So this is the mathematical representation of your signal S of n, where n is the integer 0, plus 1, minus 1, plus 2, minus 2, and so on. This is the example of one discrete type of signal. And the other way of representation, the same example is this. The meaning of both the representation are same. Here, a arrow represent a origin point. This arrow represent the value at n is equal to 0. And the right hand side will say positive values of n, and the negative side will shows a negative values of n. Or we can say at this point n is equal to 0. For this point n is positive integer, and this point n is negative integer. So we will try to sketch some continuous time signal and the discrete time signal. So for example of continuous time signal, if s of t is 2 for all values of t, we need to sketch this signal. So this is the continuous time signal, and to plot the signal, this is time axis, this is a signal. So for all values of t, its amplitude is 2. So for the positive value and the negative value, this amplitude is 2. So this is the we are going to sketch a continuous time signal. We will take another example of continuous time signal. The s of t is 2t for all values of t. So we need to sketch this one also. So this is also the example of continuous time signal. So we need to plot. This is time axis, this is magnitude axis. So for if t is 0, amplitude is 0, t is 1, amplitude is 1, 2. So plotting is like this. So at the value of 0, once you put t equal to 0, the output is 0. At the point of 0, magnitude is 0. At the point of 1, at the point of 1, once you put t equal to 1, the outcome is 2. At the once you put t equal to 2, output is 4, and so on. In the same manner, t equal to -1. So this will be -2. So this is how we can plot or sketch a continuous time signal. Now we will take the example of discrete time signal. Okay. Now we will take the example of discrete time signal. So suppose discrete time signal is this. S of n is equal to -3 plus 1, 2, 1, 2. We need to sketch this signal. This is the example of discrete time signal. To sketch as we know, this arrow shows the magnitude at the origin point. So at n equal to 0, at n equal to 0, the magnitude is 1. So for n equal to 0, magnitude is 1. For right hand side, n equal to positive integer. So this is at the value of n equal to 1. The magnitude is at the value of 1, the magnitude is 2. At the point of n equal to 2, the magnitude is 1. N equal to 3, magnitude is 2. Again, the next point is n equal to 4, magnitude is 0. That is not mentioned here. We will take the next point where the magnitude is assumed to be 0. In the same manner for the left hand side, this is n equal to negative values. So this is the origin point. So this is n equal to -1. For n equal to -1, the magnitude is -3. For n equal to -2, the magnitude assumed to be 2. So this is how we can represent our discrete time signal. We will take another example. S of n is equal to so we will take another example to plot a discrete time signal where S of n is equal to 2 for t, n for n greater than 0 or 0 for negative side. To plot this, so for n equal to 0, magnitude is 2, equal to 2, magnitude is 2, and so on, n equal to 3, 4, 5. For the negative side, n equal to -1, magnitude is 0, -2, magnitude is 0. So this is how we can plot a discrete time signal. So thank you everyone. In the next lecture, I will talk about a mathematical operation or signal transformation of the continuous time signal and the discrete time signal. Thank you.